In this example, we are going to look at adding rational expressions when they do not have the same denominator. Because we know that to add them, they have to have the same denominator or a common denominator. So we have to actually make them become the same. And we do that by multiplying them, just like we would if they were numbers. So, for example, in this case, we can see in our rational expression, we've got x plus 5 as the denominator, and then in this one, we've got x minus 3. So, these are not the same, and the easiest way to think about making them become the same is to multiply them by each other. So that means x plus 5, I want to multiply this by x minus 3 so that I'll be able to see both of these factors over here. I'm actually just going to put these in parentheses so I know they're a factor together. And I'm going to multiply by x minus 3. So I'm going to write that here, x minus 3. And whatever I do to the bottom, I also have to do to the top. X minus 3. That way I don't change the value because this is like multiplying by 1 since it's x minus 3 over x minus 3. And then on the other side, now I'm going to multiply this one here by x plus 5. So this will be times x plus 5. And whatever I do to the bottom, I should also do to the top. Again, x plus 5. And I'm going to put these in parentheses. And now I can see that these have a common denominator if I were to add them together. I'm going to do a little simplification before I do any of that. In the top here, this is x minus 3 times 2. So that means 2 times x and 2 times negative 3. I'm going to put that down here. So 2 times x, and then 2 times negative 3 would be negative 6. And then in the bottom, I've got just the same, x minus 3 times x plus 5 plus, and then on my other side, while I've got 2 of these, I need to multiply together so I can distribute or multiply. So x times x would be x squared. X times 5 would be plus 5x. So I did 1, 2. Now I'm going to go to the 2. So negative 2 times x would be minus 2x. And negative 2 times 5 would be minus 10. And then in the bottom, I have the same thing, x minus 3 and x plus 5. And now I've got 2 rational expressions with the same exact denominator. That means I can add them. I'm going to put my denominator in there first since I already know what it is, x minus 3 times x plus 5. And now I just have to figure out what goes in the top. And I can see, well, this is being added to this one. So I'm going to look for like terms that I can combine. And I can see an x squared term. It's got the highest degree. So I'm going to do that one first. And that's the only one, x squared. And then I've got 2x. And other like terms would be 5x and negative 2x. 2 and 5 makes 7. Minus 2 makes us back to 5. So plus 5x. And then I've got negative 6 and negative 10. When I add those together, that gives me negative 16. And I cannot simplify the top anymore. I can, however, multiply these two together. So just like we did up here, I'm going to kind of put this to the side. So that would be x times x, which is x squared. X times 5, which is 5x. And then I go to my next one. Negative 3 times x. And then negative 3 times 5. Negative 15. And I just wrote it on the side so that I don't have to write the fraction over and over. So I can combine my like terms here. And my final answer, I'm just going to write down here. So my top is going to stay the same. I've got x squared plus 5x minus 16. And then in the bottom, I'm looking here, so I've got x squared. 5 minus 3 makes positive 2, x minus 15. And that would be our final answer here. And when it comes to the undefined values, that's where we're looking at what makes the bottom 0. So when you cannot divide by 0. Now, it's hard to tell from our final answer what those x values are, but we know that the bottom here is the same as this, which means we already know that we have the factors. So if we set this equal to 0, we would see, well, if this one was 0, that would be 3. So one of our undefined values of x would be 3. And then our other one would be here, which would be negative 5. Because negative 5 plus 5 is 0. And if we divide by 0, that's not going to work. And we can also see that in the original problem too, because this one would have been negative 5 here, and this one would have been 3 here. So that one's done.